important check is the torsion irregularity, which is normally we have in each and every building, which is not regular. The torsion irregularity as per the C716 table 12.3-2, but I have only added these two statements that the torsion irregularity exists in the building with the maximum story drift computed including extended torsion with AX, which is the torsion amplification factor, which is normally taken as 1 at the initial stage. At one end of the story transfers to an axis in more than 1.2 times the average of the story drift at the end of two ends of the structure. So it means that the code wording is a bit difficult. So it means that when the ratio of the maximum displacement by the average displacement is greater than or equal to 2, then there is torsion irregularity in your building. Similarly, for the extreme torsion irregularity, the limit is 1.4. When the maximum delta divided by average delta is greater than or equal to 1.4, so there is extreme torsion irregularity in your building. So for the E-tab, so for the E-tab results, you have to follow the following path. So again, you have to go to the show display table, and this time results joint displacement, and this time you have to click on the diaphragm maximum and average drifts. And again, you have to insert the values in the Excel sheet. So again, if there is no torsion irregularity issue, then you have to move on towards the design. We will add these values. So let us check the torsion irregularity. I have added in the Excel sheet that this is the story level, this is the drift ratio, which is actually the drift of the diaphragm, and this is the torsion. The ratio is less than or greater than or equal to 1.2, and when the ratio is greater than or equal to 1.4. And this is the amplification factor, and this is the new torsion accidental eccentricity, and this is the maximum. We will talk about that. Let us go to the E tab and click on the display show tables. Again, you have to check the torsion irregularity against the EQX drift, right? So we will go to the displacement. This time we will select from maximum and average drifts and click OK. Select the stories again up to this. Select the X number. You can select 1, 2, 3. And this is the diaphragm X. So in this table, you can also check it manually, and it is clear that this is the maximum, this is the average, and this is the ratio, and it is 1.003, and none of the ratio is greater than 1.2. So you have to copy these values, Control C, and insert in the next sheet for the torsion, and insert this value is OK. And you can see that it is regular stories. There's no torsion irregularity in the building. Right? Let me change it, for example, and it will give you the not 1.3, right? And let me 1.4. Right? So the ratio is 1.4, so it will give you indication that there is extreme torsion irregularity. And when it is less than 1.4 but greater than 1.2, so it is only irregular, not extreme. There's no extreme in your building. And these are the values, the amplification factor and the new accidental eccentricity. These are the values used when there is torsion irregularity in the next step. So if the torsion irregularity in the building is greater than the limit specified by the code, so then you have to go to the section 12.8.4.3 to incorporate the effect of torsion irregularity. So what does the code say? It says the structure assigned to seismic category C, D, E, F, have 1A or 1B torsional resist as defined in tables. Then the effect should be accounted by multiplying MT8, which is the uh, eccentricity, which is given by the Excel sheet. So you have to multiply this factor, which is AX. Normally at initial stage, the AX is taken by the eta is 1. That the maximum displacement divided by 1 times average displacement and whole square. So this will give you a new factor, and it is known as the torsional amplification factor. And this value should not be less than 1 and should not be greater than 3. When the value is, for example, 4, then you have to take that value as 3. Right? So the Excel sheet, it will calculate the amplification factor for you, AX, and that calculate the new accidental eccentricity, which is 0.043. At initial, what we have taken in our tab was 0.05, right? So a 5% eccentricity. But in the Excel sheet, new value that is taken from this is 0.07. It means 7% eccentricity you have to incorporate in your building so that the torsion irregularity effect has been incorporated in your design. So when there is torsion irregularity, then you have to select this value and you have to insert 0.07 in your tab. Let me go to the right. So when there is torsion irregularity and you have calculated the new accidental eccentricity, then you have to insert this value as 0.05 07 instead of 0.07, right? And then okay, and then it will incorporate torsion irregularity effect in your building, right? So I've written that there is torsion irregularity in the building, then include modified torsion amplification factor in the analysis and insert the new eccentricity in your table. Next is the soft story check, and as per the ASCE, the story is classified as soft story when the lateral stiffness is less than 70% of that in the story above, or less than 80% of the average stiffness of the 3 stories, right? So in you again you have to in the E tab you have to go to the show tables, but this time go to the structure output, displacement, and story stiffnesses. Insert these values in the Excel sheet, and when there is no soft story issue, then move towards the design. But when there is soft story, then you have to take the diaphragm as semi-rigid only for that story, not for the whole building. So this is the solution. Right, so for our building, the soft story, there is no soft story in our building. You can clearly see that I have prepared this Excel sheet. You have to insert the story stiffnesses from the E tab. It will check that there is irregularity in the story, it is soft story or not. So when there is soft story, then assign the semi-rigid diaphragm to the slab at that story. You can see that the stiffness, this is 4,000 and it is 8,417, and this value is less than 75% of the above, so it is classified as soft story. So we will go to the E tab and again click on the display show tables. Check this joint, click on the structure output, other output, and click on the story stiffness. But this time you have to select the EQX and EQY, not the drift. And select the cases EQX and EQY and click OK. And it will give you the story stiffnesses for the each direction. Select the story range. Example, first the X. This is the stiffness in Q per inch and select the number is equal to 1. Copy, Control C. Let me turn off this. Go to the Excel sheet, soft story. Then insert the soft story in range. Control B. You can see that there is no soft story in our building. For example, let me reduce it. For example, the stiffness for the second story is 12,000. Not it is 1 lakh and 28,454. Let me reduce this. So let me take it, for example, 8. So it means that the stiffness of the second story is less than 75% of the third story. So the second story has been classified as soft story. So, for example, this story, the soft story, then you have to select the diaphragm of the second story in the E tab, and then you have to assign. Let me do that. For example, this is a case study, second story, and we will go to the E tab, and we will, for example, show all limits. So show all. I will go to the second story, and I will select this source. I will go to the assign shell and click on the diaphragm, modify, new diaphragm, and this time I will select semi-rigid. Okay, and I will assign this. If I right click on this, so in the assignment, you can see that the diaphragm D2, which is a semi-rigid, has been assigned to the second story only. So in this way, it will incorporate the shear forces that is coming due to the soft story. So that will be incorporated in the slab in the form of reinforcement, right? So this is the whole story about how you can include the effect of the soft story, torsional irregularity, and the drift in your proposed building. So this is the whole story about the module 5, and we will take the question answer session at the end, and we will take a 5 minutes break, and then we will move towards the module 6. Easy.